There we go. Okay, so 2.4 dividing polynomials. We're just going to do a little like throwing it back to elementary school when we would do long division, because the process here is going to be the same, but today we're going to do it with polynomials. So when I have 184 divided by 8, that means I am putting 8 into 184. So I start off by looking in how many times does 8 go into 1? It doesn't. So then I expand my search. How many times does 8 go into 18? 8 goes into 18 2 times. So I divide, kind of give a guess there. And then the process is I multiply. So 2 times 18 gives me 16. I subtract. 18 minus 16 is 2. And I bring down the next term. I'm going to use my red pen very specifically here to really point out subtraction, because when we get to polynomial division, it tends to be the most common error. So if you have something of another color that you want to use that could be helpful to draw your attention to it, I would recommend it. Definitely not required, just a suggestion. So I do kind of one cycle of this. I divide, I multiply, subtract, and bring down, and then the cycle starts over. So now I put 8 into 24. 8 goes into 24 3 times. 3 times 8 is 24. I subtract. And I get 0. There's nothing left to bring down, so that's how I know I'm done. What's left at the end? Do you remember what we call that? Yeah, remainder. So I have a remainder of 0. When I have a remainder of 0, that means that 8 goes into 184 evenly. That means that 8 is a factor of 184 because it goes in evenly. How many times does it go in? 23, for the remainder of 0. Those 3 little dots means therefore, if you're not familiar with that. So we're going to do it again. There's different ways for us to write division problems. So this has like the old school division symbol with a line and 2 dots, 1 up, 1 down. And here I have a division bar, but it's the same operation. So I have 5 going into 4,012. Five doesn't go into 4, so I kind of expand my search here and I put 5 into 40. 5 goes into 48 times. So I divide, and then I multiply. 8 times 5 is 40. I subtract. 40 minus 40 is 0. Bring down the 1. How many times does 5 go into 1? It doesn't, so I get a 0. I multiply 0 times 5 gives me 0. Subtract. 1 minus 0 is 1. Bring down the 2. So this one I have to go a whole nother round because I've got more terms to keep going. Five goes into 12 2 times. 2 times 5 is 10. Subtract and I get 2. There's nothing left to bring down. So at this point, it went a couple of different ways. You can choose to put a decimal and a 0 and keep going and put a decimal and turn it into a decimal. Or we could write this as a mixed fraction. So we're going to go for the latter. This is my remainder. Do you remember back in elementary school where they were like, okay, we're going to write 802 remainder 2? Do you remember that? And then they were like, yeah, we're not going to do that anymore. You're actually going to write it as a fraction. Then they like backtracked and changed their mind. Yeah, we're not going to do that either. Remainder 2. No. When I have a remainder, that just means it doesn't go in evenly. Okay. So when I want to write this answer, I'm going to have 802. And then when I make a mixed fraction, I have 2 remaining out of what I was dividing by. So the remainder goes in the numerator and the divisor goes in the denominator. Five does not go into 4012 evenly. Therefore, 5 is not a factor. And some of you are probably thinking like, yes, I already know how to do long division. I don't need the reminder. Cool, I'm not here to teach you long division. I'm here to emphasize the process because we're going to use it when we go from numeric long division to polynomial long division. So, polynomial division helps to find all of the zeros. There should be an S there. Zeros. Add one in. Of a polynomial function. A 0 of a function is the x value when y is 0. We're going to be talking about zeros of functions a lot, so get that down. And example 1, divide the polynomials using long division. Problem A is the polynomial x squared minus 3x plus 1, all divided by the polynomial x plus 2. So I wrote out some steps here that I think are helpful in our process. They're the same steps that we used for dividing rational numbers. Maybe with some just added language there. Some people are naturally more attuned to detail and they deal better with organization. This is one of those problems that paying attention to detail and being organized is going to truly, truly help you. I promise I've taught this for over a decade now. So I'm going to be really specific about how we do this. So the first step is to divide. I am dividing x into x squared. Or if you prefer, what is x squared divided by x? If it helps you, you can always have some scratch paper where you write this down. X squared divided by x goes in x times. Now I am going to line up my terms so that all of my like terms are in columns here. So all of my x squared is going to be in this first column. All of my x's are going to be in the next column. All of my numbers are going to be in the next column. So when I write that x, I'm going to write it right above my linear term, my x term. So step 1, divide. Step 2, multiply. So I'm going to take x and I'm going to multiply it by the entire divisor. My note says to either multiply / distribute. So x times x is x squared. I'm going to keep it in the x squared column. X times 2 is a plus 2x. I'm going to go over the first 2 steps that I already did. Step 1, I divided. X goes into x squared. How much? So if I think about x squared divided by x, I'm left with x. So I wrote it above in my x column. And then I distributed. X times x is x squared. Kept it in my squared column. X times 2 is 2x. Kept it in my x column. Any questions yet? Okay. Next, I subtract. Now, when I'm subtracting, I need to subtract both terms, which means I need to change the sign of everything here. Because if I subtract, I have x squared plus 2x, and I subtract the whole thing, and that gives me a negative x squared and a minus 2x. So this is where I'm going to use that red pen to make sure that I change the signs. So if you've got one, I'm going to subtract x squared, and I'm going to subtract the 2x. I'm going to change the signs. And I like to make it stand out so that I know I didn't forget it. That's usually where errors occur, forgetting to subtract. X squared minus x squared, right? I subtract down, this cancels. Boom. Bye. And then I have negative 3x minus 2x, which gives me minus 5x. And I bring down the next term. That's one round. We've got to do more. So I start over with my cycle. Now I'm going to divide, but now I'm putting x into minus 5x. If it helps you, when I'm putting things into, remember that's negative 5x divided by x. Which just gives me minus 5. So I divide. And I distribute. So now I'm multiplying negative 5 times x plus 2. So negative 5 times x minus 5x. Negative 5 times 2 is minus 10. I changed the signs. So I had minus 5x minus 10, and I'm going to change them both to plus. Minus 5x plus 5x cancels. It always should. Plus 1 plus 10 gives me a positive 11. Now the cycle would be to continue to bring down the next term and keep going, but I don't have anything left to bring down. So I'm done. 11 is the remainder. That means x plus 2 is not a factor of x squared minus 3x plus 1. When I divide, I get x minus 5. Now I have a remainder of 11. It's a positive 11, so I'm going to have plus 11 divided by the divisor, x plus 2. Since there's a divisor or a remainder, that means it does not go in evenly. I do not expect you to understand that after one example. We're going to do a few. Tends to be one of these skills that it feels like a difficult uphill climb, and then once you get it, you're like, oh, it's not that bad. I am going to do these in a different order because I forgot to change them from my notes. Well, no, never mind. That's fine. We'll just keep this order. It's okay. All right, so B, same directions. Now I do have an added note there. It says, if missing a term, I'm going to write it in. Just like I was doing when I was factoring binomials. You'll see here for my polynomial, I've got x cubed minus 13x minus 12. Well, when I look at my degree of my term, I have a degree 3, a degree 1, and a degree 0. I'm missing this term. I have to have that placeholder. It's super crucial. So I'm going to write it in. So I have x cubed, and I'm missing the squared term, so I'm going to write in 0x squared minus 13x minus 12. So if I remember skipping over one, like here it goes 310, I need to write in that squared term. Or if I had, 4320, I'd have to write in that x term. Here goes the process. Hopefully it feels a little bit more comfortable this time. So I'm putting x into x cubed. So that's x cubed divided by x. If you need a reminder, x cubed is just x times x times x, and I'm dividing by x. One of those cancels. That leaves me with x squared. I've got to line up my like terms. So I'm putting x into x cubed, but I'm going to write it above this term, x squared. So I divide, and then I distribute. I only divide the first term into the first term, but when I multiply, I'm going to multiply, when I multiply, I'm going to multiply x squared times the whole binomial over here. So I distribute x squared times x cubed, x squared times minus 4, minus 4x squared. I subtract. When I subtract an expression, I have to change all the signs. So the x cubed becomes negative, and the 4x squared becomes positive. So I add down. X cubed minus x cubed, that cancels. This should always cancel. If it doesn't, something went wrong. 0x squared plus 4x squared gives me 4x squared. And then minus 13x. bring down the next term, and then the process starts again. So we have x into 4x squared. Before I start the cycle, any questions that I can answer right now? Okay, x into 4x squared. So this is 4x squared divided by x, which gives me 4x. And then I distribute 4x times the outside x minus 4. 4x times x is 4x squared. 4x times negative 4 is a minus 16x. You want to subtract, so I'm going to change the signs. 4x squared is going to become negative, and the minus 16x becomes positive. Four x squared minus 4x squared cancels. Negative 13x plus 16x gives me 3x. I'm going to pause and let you do the next round. It's only a little piece of the problem. I guess I'll finish. I'll bring down the minus 12. See if you can finish it. So we're starting the cycle back over with dividing. I know this is quite the process, so if you didn't get it, that's okay. We're going to get better. The remainder should be 0, and I saw that on some paper, so that's awesome. Okay, so now I'm putting x into 3x. How many times does x go into 3x? If you need to write it out, you can. What is 3x divided by x? Oh, it's 3. So I put a plus 3 here. Then I distribute. 3 times x is 3x. 3 times negative 4 is a minus 12. I subtract or change the signs. So I subtract the 3x, add the 12. That cancels. And I'm left with 0. Remainder of 0 means my answer is just x squared plus 4x plus 3. It also means that x minus 4 is a factor of the polynomial. That means this is factorable. As we grow and develop in topic 2 and topic 3, we're going to talk about what does that mean when it's a factor? How do I find the zeros of a function? How do I continue to work with what I have left? So we're going to grow from this. When I check out all this work, you can really see the columns and how all the terms are lined up. If you get a little wonky here, it can get a little bit more confusing. So I've got a column where all I see is x cubes. I've got a column where all I see is x squares. I've got a column where all I see is x's, and a column where all I see is constants. That's what you want it to look like. Ooh, there's a typo in this one too. Should be a +3. That problem should have read 4x cubed minus 8x squared minus x plus 3, all divided by 2x plus 1. I'm going to start you off, and then I'm going to ask you to finish the problem again. Okay, so we start 2x into 4x cubed. Example C is a little bit different because instead of having just x plus or minus number, I have 2x plus a number. So just another extra thing to be aware of. I'm dividing. That's 4x cubed divided by 2x. Some of you guys can do this in your head really easily. And some people need a little more time. 4 divided by 2. Let's see, that goes in twice. And one of these x's will cancel with one of these x, and I get 2x squared. So 2x goes into 4x cubed, 2x squared times. Then I multiply 2x squared times 2x. 2 times 2 is 4. X squared times x is x cubed. 2x squared times 1, 2x squared. Change the signs. 4x cubed minus 4x cubed cancels. Negative 8x squared minus 2x squared. Negative 10x squared. And I bring down the minus x. So your next move is to put 2x into negative 10x squared. I'm going to pause this. And I want you to try to work out the rest of that problem. Okay, so my next step here, which is where I left you guys all off, is to put 2x into negative 10x squared. So I like my little side work here. It helps me keep everything straight. I have negative 10x squared divided by 2x. Well, 10 divided by negative 2 gives me a negative 5. And one of these x will cancel, so I'll get negative 5x. That goes above here. Then I distribute. Negative 5x times 2x gives me a negative 10x squared. Negative 5x times 1 gives me a minus 5x. Then I change the signs. So I get a plus 10x squared and a plus 5x. These cancel. Negative x plus 5x gives me 4x. Bring down the 3. Start the cycle over. So now I'm putting 2x into 4x. Well, 4x divided by 2x just gives me 2. So I have a positive 2. Then I distribute. 2 times 2x is 4x. 2 times 1 is 2. Change the signs. Four x minus 4x cancels. Plus 3 minus 2 gives me a 1. I have a remainder of 1. So when I divide 4x cubed minus 8x squared minus x plus 3 divided by 2x plus 1, I'm left with 2x squared minus 5x plus 2. Since the 1 is positive, I'm going to write a plus 1 divided by the divisor, which is 2x plus 1. If I have a remainder, that means 2x plus 1 is not a factor of the third degree polynomial. Okay, there's still a lot of people who need a lot more practice on this. So I've got another example. Okay, so I changed the problem that I had because I wanted to give everybody a chance to try a problem before I do one that might be a little bit more tricky. So I'm going to ask that you pause this video and do problem D, which is the polynomial 8x cubed minus 14x squared plus 8x plus 1, all divided by x minus 1. So please pause this and give that a try. Okay, so I'm going to go ahead and work this out. Hopefully you took the opportunity to try this problem. If you did it correctly, your remainder should be 3. Then I'll go ahead and work it out here. for you to check your work. Okay. So you start with x goes into 8x cubed, 8x squared times. If you're struggling with the division, remember 8x cubed is 8x times x times x, and then I'm dividing by x. One of these x's cancels, and I'm left with 8x squared. So that's what goes in my x squared column. Then I distribute 8x squared times x is 8x cubed. 8x squared times minus 1 is minus 8x squared. I change the signs and add down. 8x cubed minus 8x cubed cancels. And I have negative 14x squared plus 8x squared gives me a minus 6x squared. Bring down the next term. If this video is too fast, feel free to slow it down or pause and then restart. Then I start the process over. What is x into negative 6x squared? So negative 6x squared is negative 6 times x times x. I divide by x. One of these cancels, and I'm left with negative 6x. So negative 6x times x, negative 6x squared. Negative 6x times negative 1 is a positive 6x. Change the signs. That leaves me with 8x minus 6x, which is negative. Nope, that's a positive 2x. Bring down the 1. Start again. So x into 2x goes in 2 times. Distribute 2 times x. 2 times negative 1. Change the signs. 2x minus 2x cancels. Plus 1 plus 2 gives me a positive 3. When I have a remainder, that means that this divisor does not go into the polynomial evenly. But I can write my answer by 8x squared minus 6x plus 2. I'm going to put a plus sign before I put my fraction, positive 3, and then an x minus 1. All right. And one more. This one is just a little bit more complicated because I've got larger coefficients and a larger degree. If you feel like you understand it and you're good, then maybe you don't want to watch the last example here. But I'm going to do this one just to cover all the bases because it is slightly more than the other ones. And I'm just going to work it right out. If you want to give it a try first, go ahead. So here we go. 4x into 12x to the fourth. 12x, x, divided by 4x. So when I simplify, I get 3x cubed. Then I distribute 3x cubed times 4x, 3x cubed times negative 6. Change your signs. Oftentimes I see students not do this part, and they just think that 12x to the fourth and 12x to the fourth cancel, and they don't unless you subtract. So I emphasize that you should really use like a red or a pink or something of another color to make this stand out. 12x to the fourth minus 12x to the fourth cancels. Minus 30x plus 18x gives me a minus 12x cubed. Bring down the next term. 4x into negative 12x cubed. negative 3x squared. And I distribute negative 3x squared times 4x. And then negative 3x squared times negative 6. Change the signs and add down. Bring down the 26x and then start dividing again. 4x into negative 12x squared brings me a minus 3x. And distribute negative 3x times 4x. And negative 3x times negative 6. Get an 8x and then minus 6. And now I'm putting 4x into 8x. It goes in 2 times. And I'm left with the remainder of 6. I know that I'm done when I have nothing left to bring down. So, phew, this does not go in evenly. And I'm left with 6 out of 4x minus 6. Now, I didn't see an example of this in this out of the problems that I chose here, but please know that this remainder could be a negative number. So I could have minus 6 here, and then I would just have a minus sign instead of a plus where this is. So that's an important note. Next time I'll make sure that I pick something that has a negative remainder. Okay, and this is just the video on polynomial long division. So please look for part 2 for the rest of the section 2.4.